Okay, here are the last 4 examples. With all of these, you should be to the point where you should probably be trying them yourself first. So go ahead and write down the problem and try it. Pause, and then fast forward so that you get to the answer. Only back up if you need an explanation. All right, the integral of 8e to the x. The 8 is just a coefficient, so technically it can be moved out to the front. And you really just need the integral of e to the x, and then you're going to multiply that by 8. So we want the antiderivative of e to the x, which you should probably easily remember is e to the x. So I'm going to put the 8 in front of it and make it go from the natural log of 3 to the natural log of 6. Alright, so since there's an 8 here, you can either write it twice or factor it out. I'm going to factor it out. So the first thing that I have is e to the b, which is natural log of 6, minus e to the a, which is natural log of 3. Now don't forget your properties of logs. You have a property of logs that says that a to the log base a of anything is just that thing, right? So your base to the log with the same base, those are function inverses. And f of f inverse of x just equals x. So this just drops away and this just drops away. So your answer then is going to be 8 times 6 minus 3, or 8 times 3, or 24. Alright, for this one, the integral of cosecant cotangent, look it up if you need to, hopefully you have it memorized already, is negative cosecant x. And we're going from pi thirds to pi halves. Now do this without a calculator. Without a calculator. Alright, so we're going to have negative, which I could factor out, cosecant of pi halves minus a negative cosecant of pi thirds. So if you need some help thinking through this, the cosecant of pi halves, first I'm going to start with the sine graph. And I know that the cosecant is the reciprocal of that. So my graph goes like this. I know this is 0, pi halves, pi, and so on. So pi halves right here, that shows you that the cosecant of pi halves is 1. And I have a negative sign, so it's negative 1. And for the cosecant of pi thirds, I can draw a reference triangle in the first quadrant. Big side is square root of 3, little side, or leg, is 1, and the hypotenuse is 2. So the cosecant is the reciprocal of the sine. So it's our hypotenuse over opposite. And this is probably how I would leave the answer, except maybe write it like this, or possibly get a common denominator. And that's about it. Okay, now with this function, you can't just move whatever's in the denominator here up to the top. I mean, because it's a whole quantity, and you would still have a quantity raised to the negative 1/2. And a quantity to a power, you always have to evaluate it before you can integrate it. So let's try to think of what you can do. What you can do here is recognize this as one of your antiderivative formulas. So check out your formulas. Pause before I give you the answer because I'm going to give it to you in 3, 2, 1. Okay, this is the arc sine. You should see something like this. du, let me write this down farther, du over the square root of a squared minus u squared equals 1 over a arc sine u over a plus c. And maybe that's one of the more advanced formulas once we get to more complex things. You might just be able to find an integration formula or even your derivative formula that says the derivative of arc sine of x is 1 over the square root of 1 minus x squared. So the antiderivative of this is arc sine x. And I'm going from 0 to 0.5. Now 0.5 is a half. So for arc sine of 1/2, again, you need to get this without a calculator. to get the arcsine of a half, 1/2 is positive, so we're in the first quadrant. Your answers to arcsine are either in the first quadrant or the fourth quadrant. Let me know if we need to go over inverse trig functions in class. So your opposite side is 1, your hypotenuse is 2, and what angle is that? Because that's really what the arcsine is asking. What angle had a sine of a half? Well, it was a 6th. Now to get arcsine of 0, I would think of the graph. If I'm looking at 0, pi, pi halves, 3 pi halves, or 2 pi. So the arcsine of 0 is 0. So the answer is pi 6. Alright, the last one. Now, absolute values are really interesting. There is no formula. If you look at your antiderivative formulas, you don't have one for the absolute value. So what we have to do is figure out, what does the absolute value do to anything? Okay, you thinking? Absolute value is going to make something be positive. So the regular graph, this is what we have to think about, of y equals x minus x squared is a parabola that opens upside down, right? Because it's a negative x squared graph. So, alright, where are its x-intercepts? Let's factor out an x and c. The x-intercepts, or the zeros, are at 0 and 1. So this actual graph, and we're actually interested in this graph from negative 1 to 2, if you look at the bounds over here from negative 1 to 2, this is a parabola that looks like this. Now again, that's without the absolute value. So what's the absolute value going to do? Well, if I want to think about this graph, I'm going to make this graph in a different color. Let me make this graph in orange. Well, this graph is going to take the negative piece, which is down here, and force it to be positive. And it's going to take this negative piece and force it to be positive. So the graph that we're looking at, and this stays positive, looks like this. And if you want to graph this function in your calculator, just put in y1 equals ABS, which is the absolute value, which is found in math, num, of x minus x squared, and you will see this graph. Boom, boom, boom. Okay. So, now what is the function for this graph? Well, I mean, you think it's an absolute value, but again, absolute value by itself doesn't have a formula. So, think right here and right here, the function changed to the opposite sign of what it actually was, right? I mean, the graph being up at the top made that particular function be negative x minus x squared, where this part is actually just the positive x minus x squared. So what do? We actually have 3 separate integrals to find this answer. To find this answer, we want to integrate from negative 1 to 0, this part, negative x minus x squared, and then from here to here, which is 0 to 1, we want to integrate the actual x minus x squared, because that piece of the graph didn't have to change, so that means the function doesn't change. And then this part over here. Again, it changed signs, so we're going from 1 to 2 of negative x minus x squared. Alright, so at this point it's just a bunch of little power rules. Let's see how much I could fit on this particular page. So I'm going to do this one first. Negative x squared over 2 minus a negative gives me plus x cubed over 3. Next. Here I just need x squared over 2 minus x cubed over 3 from 0 to 1. And lastly, I need, pick a different one, negative x squared over 2 plus, because again I have a minus, a negative, x cubed over 3 from 1 to 2. And I think what I'll do, to shorten the video a little bit and to leave you something for the quiz, is ask you to finish this and submit your answer in Sophia. And that's the last of the examples.